Hi folks, we're going to take a look at this question from the homework sheet, and they want us to find the 99th derivative of this function here, sine of any multiple of x, as long as that multiple is not 0. Now there were a couple of questions that led to this one here, and in a sense you have to think about those other two before you get to this one here. So first thing to notice that when I take the derivatives of these sinusoidal functions, derivative of sine gives me cosine, and derivative of cosine gives me negative sine. So not surprisingly, if you did this, you would have seen that there were some patterns, okay? Because when I take the derivative of sine x, I get cos x, and then when I take the derivative of that, so the second derivative, I get negative sine x. Take the third derivative, so negative, and again, the derivative of sine x is cos x. And then once I get to the fourth derivative, the derivative of cos x is negative sine x, but I have this negative in front, and look what I end up with back where I started. So what we see is that the derivative of sine x repeats itself every 4 derivatives, because now, 5th, 6th, 7th, and 8th, I would just be repeating the exact same thing. Okay, so now, there was a question that had a specific k value, but I'm going to go straight to this one here. So let's start with y equals sine of kx. All right, so when I take the derivative of this here, well, again, this kx now acts like my u. So what's the derivative of sine u? It's just cos u. So cos of kx, okay? And now I have to take the derivative of u with respect to x, which is just going to be k. And I'll place that in front, okay, because I'm trying to find a pattern here. Okay, so let's continue. Take the second derivative. Sorry about that. So k is just a constant. So when I take the derivative of kx, cos of kx, I'm going to see something similar happen. Okay, derivative of cos is negative sine, so I'm going to have, negative sine of kx. Okay. All times the derivative of kx, which is equal to, again, just k. So what are we left with? We're left with negative k squared times sine of kx. And hopefully you're starting to see the pattern, because now when I take the third derivative, what starts to happen is, again, when I take that derivative of the inside function, I'm going to get another k factor, so k cubed, okay? The derivative of negative sine is going to be negative cosine, so negative cos of kx. And now let's just do one more derivative just to really show the pattern here. When I take the derivative of that interior function, I'm going to get another k, so k to the fourth. And when I take the derivative of negative cosine, I'm just going to end up with positive sine. Okay. And what we see is not quite an exact repetition, because obviously I started with sine of kx, but I do see a pattern here that I get back to sine of kx, except I now have 4 factors of k included there. And we see that the exponent of k is just going to be the number of derivatives that I've taken. All right, so the question is, how does that take me to the 99th? Well, if I had the 100th derivative, well, remember, repeats itself every 4 derivatives. So at 100, which is divisible by 4, what would I end up with? I'd end up with k to the 100 times sine of kx. So I'm just going one below that, the 99th derivative. Okay, so that means I'm going to be at this position here, 1 before the repetition of 4th, so I'm going to end up with negative k to the 99 times cos of kx. All right, and there's my answer. So just to recap, step number 1 was to realize this pattern that the derivative of sine x repeats itself every 4 derivatives. Once we added this coefficient in front of x, I realized that I had a similar repeating pattern, not quite repeating, but sine of kx after 4 derivatives brought me back to sine of kx, except each time I take the derivative, I get a new factor of k. So that allowed me to reason out the 100th derivative and then the 99th derivative. Okay, that's it for this one.